Hi, everybody, and welcome to the last unit in the Algebra 1 curriculum. We're going to be talking about statistics today, and I have to admit this is one of my favorite units to cover. I wish we were in person to go over it, but that's okay. We're going to enjoy these few lessons together. So the first thing we're going to talk about is data. So data are facts and statistics collected together for reference or analysis. Now, there's two different types of data that we're going to be looking at throughout this unit. There's qualitative data, which is also called categorical data. These are values or observations that can be sorted into groups or categories to be observed but not measured. So, for example, if I asked everybody, what's your favorite color? This is something that we can observe, but it's not necessarily something that we can actually measure in terms of the data that we would get back from everybody's responses. There's also something called quantitative data. Now, quantitative data is also known as numerical data. These are values or observations that can be measured and placed in ascending or descending order. So let's take a look at some examples now. We're going to categorize the following as qualitative or quantitative data. And the biggest thing here is to remember, can this particular category be, can this particular data be measured or not? That's what separates qualitative and quantitative data. So for example, eye color. So if I'm looking at eye color cannot be measured. If I just ask everybody, what is your eye color? That's not something where the data we're going to get back is going to be measurable. So we would classify eye color as qualitative data. It's categorical data. Favorite ice cream flavor. Same thing, qualitative data, not something, the responses are not something that can be measured. Height. Height is interesting. Height is actually quantitative data. So a person's height is measurable. Therefore, it's quantitative data. And we can put people's heights in ascending or descending order based on how tall you are. Hours spent on Instagram. Once again, quantitative data. Quantitative. Did I spell? Oh, I totally spelled this wrong on the last one. Sorry, guys. Quantitative. We have to start abbreviating here. Did I do the same thing again? I did. I'm sorry. It's been a long day. There we go. All right. Birth date. So birth date is tricky. Although your birth date, there are numbers associated with your birth date. Your birth date is not something that can actually be measured. So in this case, your birth date is qualitative data. I'm just going to say qual. Your hometown, same thing, qualitative data, not something that can be measured, just something that can be observed. Favorite sport, qualitative data. It's a category, not something that we can measure, just something we can observe. We can sort it into groups. Distance to the shopping mall. All right, so distance to a shopping mall, this is something that can be measured. It can be put in ascending or descending order. This is quantitative data. I might be 10 miles, someone else might be 5 miles to the mall. That's going to be measurable data. Number of students in a class. This is quantitative as well. Measurable data. Volume in ounces. Same thing, quantitative data. It can be measured. Gender. Gender is qualitative data. This is more categorical. Most popular breeds of dogs. Once again, this is going to be qualitative data. It's not something that we can measure. It is simply something we can observe. Someone's phone number. Okay, so phone number, don't get confused. I know there's numbers associated with phone numbers, but this is qualitative data. It's something we can observe. It is not something that we can measure. Time it takes to get dressed. This is quantitative data. We can measure this. It might take some people 5 minutes. It might take some people 10 minutes. So time it takes to get dressed is quantitative or measurable data. Zip code. Zip code, again, don't get confused. Even though there's numbers associated with a zip code, they're not measurable values. So zip code is categorical data or qualitative data. And then last but not least, number of questions correct on a quiz. This is quantitative data. I got 5 questions correct. Someone else got 10 questions correct. This is measurable data. All right, so let's keep going. Now we're going to talk about univariate data and bivariate data. So univariate, like a unicycle, which has one tire, data that represents one variable, does not deal with causes or relationships, and the purpose is to describe information. This is what we call univariate data. So an example might be how many of the students in the freshman class are female. So we're talking about one variable, number of students that are female. We're not comparing it to anything else. Bivariate data is data that represents two variables. Notice the word bi, just like in a bicycle, there's two tires. So data that represents two variables can explore causes and relationships between the data, and the purpose is to explain information. Okay, so is there a type of, is there a type of cause and effect relationship between two different variables of data? So for example, is there a relationship between the number of females in computer programming and their scores in mathematics? Okay, so let's categorize each of the following as either univariate or bivariate data, and then state the variables involved. So number 1 says, you ask the ages of the first 50 students to arrive at school. Okay. So all we're talking about is age of students that are arriving. So this is what we would call univariate. And the variable in particular here is age of students. So I'm just going to put a little dash here. Age of students. Number 2, you ask the first 50 students who arrive at school how much time they spend doing homework per week and their GPA. So you'll notice this word "and" is going to appear mostly when you see bivariate data. So we're comparing two different variables here. So the first thing we're talking about is how much time they spend doing homework per week. So hours spent doing homework per week. And the next variable is GPA. So it might be, is there some type of relationship between hours spent doing homework and a person's GPA? So looking at number 3, you conduct a survey to see how many students in the 6th grade own a cell phone. Is this univariate data or bivariate data? Well, really, the only thing that we're talking about here is students owning a cell phone, and that is going to be categorized as univariate. And the variable that we're looking at here is students that own a cell phone. Okay. And then number 4, you conduct a survey to see if there is a relationship between how many 6th graders own cell phones and their math final exam score. All right, so this is bivariate data that "and" is connecting two variables. So in this case, we're comparing students that own cell phones and their math final exam score. Okay, so is it if you own a cell phone, does that ultimately mean that you have a higher math final exam score? Who knows? So this is information that we would look at to see if there is some type of relationship there. Okay, all right, moving on. Now we're going to talk about causal relationships. So not casual, be very careful here, causal relationships. So when one event is the result of the occurrence of the other event. So when we say causal, we're talking about cause and effect. Is one thing causing the other to happen. So cause and effect. So for example, after the constant rain last week, the canal began to overflow. So the reason the canal overflowed is because of that constant rain. That's a cause and effect relationship. So now we're going to determine whether each represents a causal relationship. Is this a cause and effect relationship taking place here? The rooster crows and the sun rises. So let's think about this for a second. Does the sun rise because the rooster crowed? No. So this is not a causal relationship here. And the reason for that is the sun is not rising because the rooster crows. It's actually the opposite. The sun rises and the rooster crows. That would make it a causal relationship. All right, number 2, the more miles driven, the more gasoline needed. Yes, I would say this is a cause and effect relationship. If you're going to drive a far distance, you're going to need a lot of gas. Number 3, the more powerful the microwave, the faster the food cooks. Is this a cause and effect relationship? Yes, it is. If your microwave is powerful, your food will cook faster. That's what makes your food cook faster, is the power of the microwave. Number 4, the faster the pace of a runner, the quicker the runner finishes. Well, absolutely. Isn't that what a race is all about? Whoever's the fastest is going to win. So this is definitely a cause and effect relationship. The number of miles walked and the total calories burned. This is definitely cause and effect. Obviously, the more or the further you go, the more calories you're ultimately going to burn because you're going to be using energy. Number 6, the population of a country and the census taken every 10 years. Okay, so let's think about this as a cause and effect relationship. Does the population of a country cause a census to be taken every 10 years? Well, I would say it's kind of the opposite, right? You conduct the census in order to get an idea of the population of a country. So in this case, this is not necessarily, the way it's written, this is not a cause and effect relationship. Last but not least, the month changes from November to December, and it starts to snow. So I don't think the snow just waits for the months to change. I think it's going to snow when the weather reaches a certain temperature and when a lot of other things start to happen. So in this case, this is not a cause and effect relationship. The snow is not waiting for the month to change from November to December in order to fall. All right. Now we're going to do a little bit of review. So we're going to talk about measures of central tendency. Now you guys did this, actually I think it might have been last year in 6th grade. So I know definitely 6th grade for sure. So measures of central tendency, we're talking about mean, median, and mode. So the mean is the average of a set of numbers. Remember, average is you add all the numbers together and you divide by the total number that you have. Median is the numbers in the middle when the data is in numerical order. Now, typically, if you have an odd number of data, then there should be one number in the middle. However, if you have an even number of data, then you're going to have to do some averaging between the middle two numbers. Last but not least, mode. Mode is the number with the highest frequency in a set of data. So which number do you see most often? When there are outliers, so this is important, when there are outliers in the data, the median should be used rather than the mean. Outliers are going to pull the mean towards really their direction, so whether higher or lower. So it's not going to give us an accurate picture of really what's going on with our data. The median is going to be a much clearer picture and better idea of what's going on. So let's take a look. Number 8, which uses the table at the right here. The values of 11 houses on Calkins Road are shown in the table. So value per house, $100,000. There's one house that's $100,000. There's 5 houses that are valued at $175,000. 4 houses valued at $200,000. And 1 house valued at $700,000. So if I'm looking at this, I'm noticing that 700,000 is an outlier. And the reason for that is it is a much higher value than the rest of the numbers. In fact, it's more than 1.5 times the other values there. So this is what we would classify as an outlier. So the first thing we're going to do, 8A, asks us to find the mean value of these houses in dollars. So mean, remember, is average. So I'm going to take, and you can plug this right into your graphing calculator this exact way if you would like. I'm going to take $100,000, and there's only one house that has that value, plus $175,000, and I'm going to multiply that by 5. So I'm going to put the 5 in parentheses because technically there's 5 houses at that value. Then I'm going to add 200,000 times 4 because there's 4 houses that are valued at $200,000. And then lastly, I'm going to add that one $700,000 house to the rest of the group. All right, so when I add all these together, I get 2,475,000. And now I'm going to divide that by 11. And the reason I'm going to divide it by 11 is because we're talking about 11 houses. So dividing by 11 gives us a mean or an average of $225,000. Now, if you're looking at the mean and you are looking at the value per house, you see that that mean is pretty high. The mean is greater than the value of 10 out of the 11 houses. So you see how that outlier of $700,000 really affected the mean. It really brought up the value of the mean, and it doesn't really give us a clear picture or a very distinct picture of what the actual house values are for these 11 houses. So now we're going to find the median value of these houses in dollars. So we have 11 houses total, which is an odd number. So we're going to have to do some averaging between the two middle values. So if I take 11 and I divide that in half, I get 5.5. So what does that tell me? That tells me I need to average the 5th and 6th value to get the median. So the 5th and 6th house value, if we were to put these in order from least to greatest, so we would have one house at 100,000, we would have 175,000 listed 5 times, and 200,000 listed 4 times, and 700,000 listed once. I'm looking for the 5th and the 6th value. Now, with that being said, if I have one $100,000 house followed by 5 $175,000 houses, my 5th and 6th values are going to come at 175,000. Okay, so 1 and then 2, 3, 4, 5, 6. 5 and 6 still fall under that $175,000 category. So seeing as they're the exact same value, no averaging really needs to take place. We just know that the median is $175,000 because that's where the 5th and 6th values lie. Okay, so state which measure of central tendency, the mean or the median, best represents the values of these 11 houses, and explain. Well, just looking at these two values, kind of like I said earlier, that mean is greater than 10 out of the 11 houses in terms of value. So personally, I don't feel like the mean is really giving a clear representation of the value of these 11 houses because of that outlier, because of that one $700,000 house. So which measure of central tendency then best represents the value of these 11 houses? The median does. And the reason for this is because, so median, and we'll say because the outlier, which is 700,000, does not affect the value. Okay. All right. Part D, if you lived on Calkins Road and were going to put your house up for sale, which measure of central tendency would you use to advertise your house? Why? Okay, so this is a little different type of question. So in this question, if I was going to put my house up for sale, personally, I would say I would use the mean in this case. And the reason for that is I could say that the average home price for a house on Calkins Road is $225,000. But maybe I'm pricing mine below that. Maybe I'm pricing mine more towards the median value. I might be saying, look, the mean value is $225,000, but I'm selling mine for well below the average value. So in this case, I would personally, so I would use mean because you could say the average home price is $225,000, but I'm selling mine for well below the average. This would tend to make people happy to see that. All right, they want to know they're getting a good deal. Okay, so now let's go on to number 9. So number 9, we're going to be using the table at the right. It says which interval contains the median. So we have intervals of 14 to 16, 17 to 19, 20 to 22, 23 to 25. Frequency means how often the data falls within that interval. So we have 2 pieces of data that fall between 14 and 16, 6 pieces of data that fall between 17 and 19. 9 that fall between 20 and 22, 8 that fall between 23 and 25. Now, we don't necessarily know what they're talking about here. We just know that there's this given interval, and frequency is how often data occurs within that interval. So let's see. If I'm looking at really the total number of data, the total pieces of data that we have here, I'm going to add up my frequency values. So 2 plus 6 plus 9 plus 8, that gives us 25 total pieces of data that we're working with here. So to find the median, since 25 is an odd number, I'm going to cut this in half, and that gives me 12.5. So that means the median is the average of 12 of the 12th and 13th data values. Now, going in order, where do the 12th and 13th data values lie? In what intervals do they lie? Well, if I'm adding, okay, and I'm going to follow in order my frequency here, so 2 plus 6 gives me 8 pieces of data that fall between 14 to 16 and 17 to 19, okay? So 8 plus 9, that gives me 17. Now, that means that somewhere within this 20 to 22 interval are the 12th and 13th data value pieces. So in this case, our median falls within the interval of 20 to 22. We know the 12th and 13th data values fall within that interval. All right, last but not least, number 10. If n represents the smallest of 4 consecutive integers, write an expression for the mean of the numbers. All right, so let's think about what consecutive integers means, okay? We're going back to earlier this year and even the end of last year for you guys. So if I say let n equal the first, I'm going to say CI, consecutive integer. Then n plus 1 is the second consecutive integer. And n plus 2, because remember, consecutive integers means they're one right after the other. 1, 2, 3, 4, 5. So n plus 2 is going to be the third consecutive integer. And finally, let n plus 3 be our fourth consecutive integer. Now, if we're talking about the mean, remember, we're going to add these numbers together. Okay, we don't necessarily know them, but we're going to add them together, and we're going to divide by 4 because we're talking about 4 numbers that we want to find the mean of. So I would take n plus n plus 1 plus n plus 2 plus n plus 3. You don't need the parentheses here. They're just going to drop out anyways. I'm just showing all the different numbers and their representations. And we divide that by 4. Okay, so I'm just going to simplify this a little bit. So n plus n plus n, n plus n plus n plus n, 4n. And then 1 plus 2 plus 3 gives me 6, all divided by 4. So here's an expression for the mean of the numbers if you want to take this a step further and actually simplify this fraction down a little bit. We could simplify that. 4n divided by 4 gives us just n, plus, let's see, 6 divided by 4, simplify that to 3 halves. So either one of these would work. In this case, if you didn't feel like simplifying it, that's okay. 4n plus 6 over 4 is just fine. All right, so there is your introduction to statistics. Tomorrow, you're going to be moving on to representing data graphically.